Okay, problem one. First thing we're going to do is condense our logs. So we are going to have log base 2 of 5 minus x over 9 equals 3. And then on this whole page, we just want to be hitting it with the water cycle. So we're going to do 2 to the third, which is 8, and then say 8 equals 5 minus x over 9. And then we're going to multiply both sides by 9. And we're going to get 72 equals 5 minus x. When you solve this equation out, move the x, move the 72, you'll get x equals negative 67. And when you plug that back in up here where the arrow is pointing, it becomes 5 plus 67, which is just fine. So this answer is good. On to number 2. We're going to condense, and this condensing happens through multiplication. So we're going to have log base 4 of 4x squared plus 11x plus 7 equals 0. And when you hit this one with the water cycle and you take 4 to the power of 0, you get 1. So we wind up with 1 equals 4x squared plus 11x plus 7. And then we're going to move the 1 to the other side. So we're going to have 4x squared plus 11x plus 6 equals 0. And this will factor down into 4x plus 3 times x plus 2, which means that our maybe solutions are x equals negative 3/4 and x equals negative 2. And in this video, I won't go through every little detail of checking your answers. Just know that negative 3/4 will work and negative 2 will not, because it's going to give you negative log arguments. So negative 3/4 stays, negative 2 gets crossed out. On to number 3, condensing. We're going to have log base 2 of, and you do have to multiply these arguments together, so you get 6x squared minus 42. And then you're going to hit it with the water cycle, and 2 to the power of 2 is 4. So we have 4 equals 6x squared minus 42. And then you're just going to move some stuff around. I'm going to have 6x squared equals 46. And then when you divide both sides by 6, you wind up at x squared equals 23 divided by 3. And it's at this point that you take the square root of both sides. And you wind up with x equals positive negative root 23 over root 3. But you'll recall that we can't leave the root in the bottom. So we multiply the top and the bottom, and we wind up with a final answer of x equals positive negative root 69 over 3. And again, I will dispense with the details. Just know that when you put those either positive or negative, it doesn't matter, because up here in this little green circle thing, you square it, so it becomes positive anyways. And when you put that in your calculator, the x squared is big enough that when you subtract 7, the log argument stays positive. So this can have a box. So I would state on this problem that x equals positive negative root 69 over 3. So box it up. Number 4, we're going to do a condensing here. So we're going to have log base 5 of x plus 10 over x minus 6 equals log base 5 of x plus 1. This is the only problem on the practice quiz like this, but because both sides are the same, log base 5, log base 5, this is one where the logs cancel, drop, fall away, whatever, and we're left with just x plus 10 over x minus 6 equals x plus 1. And algebra is algebra, so we multiply both sides by x minus 6. And then those cancel over here, and we're left with x plus 10 equals x squared minus 5x minus 6. And because it's a normal three-term quadratic, like all the terms are accounted for, this is a move everything to one side kind of problem. So we're going to leave x squared. We're going to now have minus 6x, and we're going to have minus 16. And when we factor this down, I'll do it over here, we get x minus 8 times x plus 2. Those are the factors that work. Therefore, the answers, the candidates are x equals 8 and x equals negative 2. And if you put 8 in, you'll encounter no problems. So he can have a box. If you put in negative 2, you will encounter a problem in both of the arguments up here that I'm circling in red. They will both produce an issue because you get negative log arguments, which, as you know, is not allowed. So you're going to cross that one out. Problem 5. 5 and 6 bring a lot of stress along with them because we have to tote around E. So let's start by just condensing. So this is going to be a natural log of x over x minus 4 equals 5. Just remember that this natural log over here is a log with a base of E. So when you water cycle this out, you get e to the 5th equals x over x minus 4. And again, just like a couple problems ago, when you see a fraction, you get rid of the fraction. So we're going to multiply by x minus 4 on both sides. And we're going to cancel those out. Our left side, don't forget that you have to distribute like that. So our left side winds up saying e to the 5th x minus 4 e to the 5th. And then the right side is just the x because we pulled the bottom out. The key here is to get your x's on the same side. So I'm going to leave my e to the 5th x just hanging out here. I'm going to bring this x over by subtracting him. And then I'm going to move the 4e to the 5th to the right and make him positive. And again, the key here is that I got the x's in the same place, well, on the same side. So I can now sort of reverse distribute, common factor. So I'm going to pull the x out, and that leaves behind e to the 5th minus 1. And then the last step is to divide both sides by whatever's attached to the x, which in this case is e to the 5th minus 1. These cancel, and we're left with our answer. So your answer to problem number 5 should say then that x equals 4e to the 5th over e to the 5th minus 1. And before we box it up or cross it out, just be advised, you want to have a good calculator with you when you take tests like this, because your calculator, when you type this in, will tell you that the value of this is around 4.0271. There's more decimal places, but that should be detailed enough that when you go put that back up in the original problem, right up here where this red arrow is pointing, the fact that it's 4 point something means that if I do that minus 4, this argument of this log stays positive, and this first one is obviously positive. And so I'm going to take this answer and commit to it and say this works. So that gets a box. Problem number 6 is about as annoying as problem number 5. But again, the step that we have to do first is condensing. So we wind up with the natural log of, and we are going to multiply. So again, it's distribution. So we're going to have the natural log of 6x squared minus 12 equals 3. Don't forget, that's a log with a base of e. So when we water cycle this up, we get e cubed equals 6x squared minus 12. And then again, it's just algebraic basics from this point. I'm going to leave the 6x squared on his own side, and I'm going to add the 12 across to be with the e cubed. So we have e cubed plus 12. And then I'm going to divide both sides by 6. And when I divide both sides by 6 here and here, I get now almost to the end where I say x squared equals e cubed plus 12 over 6. Because x is squared, we have to square root both sides. So we wind up with this. X equals positive negative square root of e cubed plus 12 over square root of 6. And again, for the second time, you can't leave a square root on the bottom. So we multiply the top and the bottom both by the square root of 6. And that when these roots up on top multiply together, you wind up essentially distributing because you just multiply the things on the inside. So we can say for a final maybe answer that x equals positive negative root 6 e cubed plus 72 over 6. And again, having a good calculator is a really good idea because your calculator will tell you that this stuff right here is approximately equal to 2.3125. I did a tiny bit of rounding there, but again, 4 decimal places, it's usually going to be enough. And so if you take that 2.3125 and you put it up in here where this arrow is pointing, and you square it, you get enough that when you subtract 2, you're still positive, so we don't have any problems. So again, I can box this up. Having tested it and verified that it comes out positive, like all my log arguments come out positive, then I can box it up. Page 2, the problems all are going to be pretty similar to each other, so let's take a look. So, in all these, the critical skill happens right away, and you have to be good at the water cycle part, meaning, so like for this first one, I'll do a little bit of detail on this one, and then I'm not going to anymore. But your first step is to take that and raise it to the power of that. And I'm going to erase this in a second since I'm recording, but if you take x plus 10 and you square it, again, this, you can't really get through this quiz if you botch this step, so this has to be solid. You identify inside the parentheses that there are 2 things. There's an x and a plus 10. And it's this, the thing I keep saying in class is square, square, multiply, double. So if you square the red box, you get x squared. If you square the green box, you get plus 100. But what people sometimes forget is that you also have to go multiply double. So if you take the red and the green and you multiply them, you get 10x plus 10x. And then if you double that, you get plus 20x. And so that's how you begin. And again, I'm not going to go through that every time, but that's what I'm doing every time I start any problem on this page. I'm doing that process. So having said that, I'm going to get rid of some of my work and I'm going to pull this up here. And so this has to then be equal to the stuff inside the argument of the log, which is 2x squared plus 19x plus 28. And then from here, it's just quadratics 101. We want to move all of our stuff to the right in this case. So we get a positive x squared, subtract 20x, we get minus x, subtract 100, we get minus 72, set it equal to 0, and factor. Therefore, the numbers that might be answers are x equals positive 9 and x equals negative 8. And neither one of these is going to pose any problems. Again, to save time, I will let you go through that. But if you put 9 where all the x's are, you encounter no difficulties. If you put negative 8 where all the x's are, you encounter no difficulties. So each of them can have a box. They're both valid solutions. Question 8, right out of the gate, we do x minus 2 to the second power. So your first thing should say x squared minus 4x plus 4. And we're going to set that equal to the argument of the log, which is 2x squared minus 2x plus 1. And again, I just have to be smart about which side I move stuff to. Again, I want the right side so that x squared stays positive. So I have x squared, add 4x gives me plus 2x, minus 4 gives me minus 3. Set that equal to 0, and we factor. And the factors are, of course, x plus 3 and x minus 1, leaving us with potential answers of x equals negative 3 and x equals positive 1. These will both pose problems right away. If you put either of them in where this arrow is pointing, you're going to get a log with a negative base. And we know that that's just like right out of the gate, a rule that we can't break. So this one doesn't work. This one doesn't work. And we have to state then, okay, so what is your conclusion? My conclusion is that there is then no real solution to this equation. So expect that that could happen, right? Sometimes just nothing that we get works, and it is what it is. All right, on to number 9. Same thing, start with the water cycle. So x minus 4 squared is x squared minus 8x plus 16. And we're going to set that equal to 4x squared minus 27x plus 32. And yet again, kind of feels a little repetitive. We're moving everything to the right. And we're doing that just, again, to keep x squared from going negative. So if you subtract x squared across, you get 3 of those. Add 8x, you get minus 19 of those. And then subtract 16, you're left with plus 16 of those. And then this will factor down into 3x minus 16 and x minus 1. That's the combination that we're looking for. So our potential answers are x equals 16 thirds and x equals positive 1. And if you put 1 in, I'll go up here again and draw a little arrow. If you put 1 in right there, you're busted right away because the log base goes negative, so he's out. I think in a case like this, what I would tell you is make sure when you're working through problems like this that you understand 16 thirds. If you use a calculator a lot, then you can probably just get by. But if you're someone who likes to understand things a little bit better, think of 16 thirds as 5 with a third left over. And it's not going to accomplish everything you need, but it kind of helps to give us perspective. So when you put it back up here where the arrow is, he passes the first test because 5 and a third minus 4 is 1 and 1/3. And that's a legal base. And then if you put 5 and a third, you could even round it off and probably call it like 5.3333. Keep enough decimal places to be respectful of the number. But if you plug it back up in here and all in place of all these x's, you will wind up with this argument being positive. And so 16 thirds passes the test. So he can have a box, whereas 1 got across. Problem 10, again, starts out right away with this to the power of this, and 3x squared is 9x squared. And then we set that equal to the argument of the log. And this time we are going to move everything to the left, just again, because we base everything on where will x squared stay positive. So I'm going to have 3 of those over here, minus 2x's and minus 8, because everybody's coming across and changing signs. This will factor down into 3x plus 4 and x minus 2, meaning that our potential answers are x equals negative 1 and 1/3, negative 4/3, and x equals positive 2. And you can see right away that negative 4/3 gets an insta-fail because if you put it up here where the arrow is, that's a 3 times negative, and that's just got to be negative, so he's out right away. And if you go through and put in 2, you see absolutely no issues that could even possibly arise. So you don't have to do much math there, just kind of common sense and see that everything's going to stay positive. So 2 is just fine. Number 11, start with the water cycle. 2x plus 3 squared is 4x squared plus 12x plus 9. And we're going to set that equal to 3x squared plus 9x plus 7. And again, if you'll feel this way, we should move everything to the left. So we're going to have 1x squared left. If you subtract 9, you're left with plus 3x's. And if you subtract 7, you're left with plus 2. So that's some pretty simple factoring right there, right? X plus 1 and x plus 2. It's the only way that could work. So your maybe answers are x equals -1 and x equals -2. And again, what you're going to find is that neither of them works. I can tell you the one that's obvious to people is the -2. So I just want to show you this real quick. So I'm going to slow down at one point in this video. It's right now. If you put -2 up here where the arrow is pointing, everyone catches this one because 2 times -2 is -4 plus 3 is -1. And everyone seems to remember that rule that the base of a log can't be negative. So like everyone's 100% really quick to cross that one out, which is great. The trouble is this other one. And if you put -1 in there, you get 2 times -1 plus 3, which is -2 plus 3, which is 1. And it's really easy to want to put a box around that -1 because sometimes we don't catch it. But you do have to remember that there's an extra rule for bases. With a base of a log, it can't be 0, it can't be negative, but it also can't be 1. And because the base comes out as 1, this one also has to get crossed out. So watch out for that. And that means that yet again, there is no solution. Which leads us to the last problem. And the last problem is, again, we start with the water cycle. So this to the power of 2. And that if you cycle it or multiply it correctly, square, square, multiply double, you get 16x squared minus 8x plus 1. And you're going to set that equal to the argument of the log, which is 8x squared plus x. We just kind of flow vibe with the problem. The problem is telling me to take all this and move it over to the left. So I'm going to get 8x squareds when I'm done. When I subtract one more x across, I get minus 9x and then plus 1. And the factoring on this will check out to be 8x minus 1 and x minus 1, leaving our maybe answers as x equals 1 over 8 and x equals positive 1. If you put in positive 1, I'll do the little red arrow again, way up here at the top of the screen. If you put 1 there, you're obviously in trouble because -4 times 1 is -4, and -4 plus 1 is -3. So boom, busted. 1/8 works. And I'll show you the math of it kind of over here off to the side. So if you do -4 times 1/8 plus 1. So this is the base of the log kind of magnified here, blown up. So -4 times 1/8 is like -4 over 8, which is -1/2. And -1/2 plus 1 equals positive 1/2. So he does pass the first test. And then I could tell you, like, if you're good with your calculator, you could just type it into this. I'll use green here. The green box is our other concern. And if this is actually going to work, it has to pass the green box test also. So if you are good with typing fractions into your calculator, then ignore the next 20 seconds. If you would prefer to use decimals, just know that 1/8, if you put it in, is equal to 0.125. So you could type into your calculator like 8 times 0.125 squared plus 0.125. But again, I mean, all that is really silly because, again, it's just a bunch of positives. There's no negatives anywhere. So that one I think is pretty obvious that it works. So I would give 1/8 the box, whereas I gave negative or positive 1, excuse me, a cross out. So if you have any questions, tomorrow's your quiz. Let me know. I hope you found this to be helpful. But I'll just kind of run through the pages again so you can scan through the answers. So there's number 1. There's number 2. There's number 3. There's number 4. The answers I kind of put off to the side here. I went off the page. There's number 5 down there. And there's number 6 down there. So, all right, let me know if I can help. The quiz tomorrow will probably have less questions if you're watching this. I'm going to try to get it down to 4 on the front and 4 on the back. So not a guarantee, but that's kind of the goal. So it certainly won't be any longer than 6 and 6, but I'll try to get it down to 4 and 4. Okay, bye.